So, good afternoon. I hope still some energy is left in you to listen to my presentation. We from the industry are always fighting with the lunch, so it's our problem. So, I want to give the topic of my presentation is our newest machine called Unity. It's an MRI Linux. And I want really briefly to inform you about how we managed to succeed to bring these two worlds together, an MRI Linux and MRI with a Linux, and how we see the future of with this equipment. On the 18th of June, we got the CE mark for Unity, for the MRI Linux. So we are since then in Europe clinical, and we are really celebrating this this success because we had a lot of doubts in the community that we will succeed in this to bring these two worlds together, and we did it. You see in the right corner the clinics where we have installed the machines. One of the slides is also Wisconsin, if I understand right. Robert is from Wisconsin, and there is a Unity installed, and it's also a member of the consortium. There are 7 founding members. And you will see here really famous clinics like MD Anderson, Utrecht, etc. I will come in the next slides. I will come to this topic. Why MRI? Why MRI radiation therapy? Why we choose that? Why we think that this is the way for modern radiation therapy? Radiation therapy has come really a long way in a short period of time, and when you got the introduction of the image guidance and the IMRT, this has changed the radiation therapy and dramatically in a positive way. And but although we still have some challenges, and one of the challenges is what we heard from the presentations previous, is the uncertainty of position, of shape and motion of the tube. Also, with this limited information, it's not easy to adapt your plan, to adapt treatment previous and during the treatment. Also, what is a main problem that regarding the organs and risk, that you as you extend your PTV, also the organs and risk and will be higher irradiate, and that's also a problem. How we see what is required to address these challenges, how to solve it. The best way to address these uncertainties is about the position, the shape, and the motion of the tumor is to improve target and organs at risk visualization with a high quality and high speed imaging in real time. An additional requirement would be also to have to work with marker-free targets and tracking the motion without markers and without surrogates. This would increase the confidence to reduce the PTV to lower the dose and the organs at risk, and also we would push for new treatment regimes. Regarding multiparametric and functional information, to get more information from functional imaging and to get the biological response, how the tumor responds on your treatment, and the characterization is also very important. What is today the role of high-field MRI? First, we use it as a diagnostics, as an MRI scanner. Then secondly, for the simulation. Also for the treatment planning, we use the imaging. And last not least, we are using today also for the response assessment, what we had here also from the previous presentations. From today, we are filling the gap that you can use. You have also a machine, what you can use also for the treatment with the MRI. What are the potential benefits of online high-field MRI? First, soft tissue visualization, what improved ability to adapt your treatment. Secondly, also the ability to see the tumor and the organs at risk. Secondly, real-time imaging during irradiation and tracking without surrogates. Thirdly, it's non-invasive. You have not extra dose to the healthy tissue, no imaging dose, and no implant markers. And beyond the imaging, you will get a total different. You will have a total different knowledge about information during the treatment, the dose you deliver, then also the quantitative results, and also how the tumor is responding on your treatment. That's very, very important. When we introduced the cone beam CT, it was really a great improvement and over previous technologies. And for certain anatomies, it's really, really good. But still we have some uncertainties and challenges, what we see also in previous presentations. And here we see a comparison between the cone beam CT and the MR. And you see here the prostate on the left side, and on the right side you see the prostate with the MR. And it's really visible that the quality of the scan is much more better. So, Elekta developed the Unity together, and that's a standard together with customers. And here are the founding members of the consortium. And here you see the first member was Utrecht, and then you see also AWL, Royal Marston, Christie, Sunnybrook, MD Anderson, and last but not least Wisconsin. With them together, we are developing also certain strategies how the further development will go on. We have 15 MR Linux installed at the moment, 7 at the consortium members, 5 in our R&D facility in UK, 3 sites the installation is ongoing, and we will have very soon also, here you see the whole group of sites, they will have Unity very soon. So Very famous clinics like Memorial First Kettering, Tübingen, Uppsala, etc. are under these names. Professor Bas Rijmaker, I think most of you know him. He is one of the founder and creator of the MRI Linac, and you see here the history behind how development was. From 99, the idea was born in Utrecht together with Elekta and with Philips. Then the first prototype was developed in 2009 from Utrecht. Elekta's commitment was coming in 2011 to make this product, and the first consortium meeting was in 2012. So the journey was not so short. We think that the story about Unity is focused on three areas. The technology is groundbreaking in his approach. First, we think that we are bringing with this technology a personalized therapy, and it has really an extraordinary potential for the future. So here's some data. So it's a 1.5 Tesla MRI based on Philips Ingenia. It's a short, wide, 70 centimeters bore with an optimized coil for radiotherapy. We developed from scratch a new linear accelerator with an agility-based MLC, and it has the slip ring technology with 360 degrees. It's rotate around the MRI. And the brain behind these two technologies is the intelligent software who integrates these two technologies that you can do an online adaptive planning, adapt to position, adapt to shape, and you have a unique particle transport algorithm behind. So how we managed to bring MRI together with the linear accelerators? What is the main problem? The radio frequency and the magnetic interference is the main problem between two systems. And you see here, here on the right side, you see the U shape. Normally you have in the room, in a normal MRI room, you have an RF cage. Here we made an U-shape RF cage around the linear accelerator, and everything what is colored here brown is the cage. So it is protected from interferences from outside and from also the isolation of the MRI from the linac is that the beam is going through the MRI. The magnet coils are specifically designed such that the active shielding protect the linac, and also such the radiation beam can pass, as I said, through the MRI. The system has also a beam stopper, so that with the beam stopper you don't need primary shielding, and on the beam stopper you have also an MV imaging device what is mounted in front of the beam stopper, and it's for calibration purposes. An MRI linac, so Unity fits into a normal bunker. So The intelligent software is the brain who links this, the imaging and the treatment delivery technology. There are several different workflow tasks, and to get most out of these platforms, you need the perfect tool at the right time. So you have really a huge amount of data from the imaging, you have what you have to manage, and you have also to do very fast, for adaptive planning, very fast calculation and recalculation. The software, the suite is created like a cockpit, and it's allowing the operator to drive the machine to get the best clinical outcome with this software. We focused not only on imaging and treatment delivery, we focused also on patient positioning in that system. So I don't know if you see it. With Elekta Unity opens also a new treatment paradigms, starting with the patient positioning. There is no lasers needed anymore. Indexing, we have an indexing patient positioning device on the table, what you see on the left side, and this ensures a very accurate setup of the patient. I will switch here to the next. So as soon the patient is lying on the couch, the coil has been placed. Then the patient is moved into the bore in a predefined position. I will go on because as the time is very short. Here we have a case where we have compared, this is a prostate case where we have made a comparison between Elekta Unity and the Versa HD. It's a 7-field step and shoot IRT. Then here we have a head and neck case, 9-field step and shoot. And then here a lung case, a 9-field SBRT, step and shoot. Here's some short information about the servicing, because you know that it was a problem which kind of tools we will use and how to approach the linear accelerators because of the magnetic field, and we succeed to make it in a very easy way. You are 1 meter working. We have only 1 meter working height, and you see it's a very easy approach, and it's away from the magnet, so you can work with normal tools. And we developed also a special servicing. We call it SISO, shift in, shift out, and this design enables you that you can change the parts very easy and very fast with no need of recalibration. So, and these are the consortium members, 7 of them, and with Philips and Elekta together. And since a few months or 1 year, everybody who is buying a Unity can become a consortium member and can bring in his expertise can bring his knowledge and work in the tumor groups. Here very shortly on which areas the consortium is focused. First of all, on optimization of the image, of the sequences, what is very important. Then patient and machine QA, health economics and reimbursement, because it's a total new treatment. So, and then the adaptive elements for the treatment planning. They're working on the clinical workflow and also on the clinical values. We have in total 9 tumor boards where they work on different indications also. Very shortly about the how we think that this patient-centric platform will allow you to respond to live images while the patient is on the table. In today's radiation therapy, typically the treatment plan is prepared before the treatment and applied throughout treatment delivery. And while this is generally accepted as a standard of care, such target localization may still deviate from actual position and shape of the target. You see here, with the Unity, you can adapt your position, you can adapt your PTV, you can adapt also your dose daily when the patient is on the table. I will switch this. We have, regarding the workflow, we have two strategies regarding the workflow. We have adapt to position and adapt to shape. And here on the left and the right side, you see the indications. I don't want to go deeper in this slide, but behind you have also software who is supporting you to make the right decision. So, only 1 or 2 charts more. We think that we have now also hope for these special indications with the visibility of the soft tissue, and this will give also to the patient a new hope and a new tool for you to treat the patient. We think that with this system we are ready for the future, and with functional imaging, and you will get with the biological response, you have a higher potential to earlier adapt your treatment and to be more proactive in your treatments and in your planning. Sorry. So, this is a statement from our VP for Research and Innovation, and it was really amazing for me to read that when the first MLC came out, we thought that, and the clinicians thought that it will be used only for 30% in the clinics, and today it's impossible to imagine to work without an MLC. What I'm showing here is the developments, and in Elekta we are a company who see as a leading role in innovations, and we developed we have really huge and very interesting developments in the past, and we think that this will, with Unity, this will be a really unique journey. To summarize, that we think that the future is in precision. Unity will forever change the way that radiotherapy is conducted. It's not only changing from cone beam to MRI. No, it's not only that. We think that in 5 to 10 years, you will forgot about planning. You will not have more a reference plan. You will plan on the fly. That means when the patient is on the table, on the Unity table, you will do your plan and your treatment. As we also think that this will reduce also the fractions, and the hypofractionation will bring a high benefit for the patient, and it will be cost effective also for the healthcare. And yes, thank you very much for your patience.